PhD research, which aims to evaluate practice design, specifically in junior performance tennis. So my PhD is in association with the LTA, so the governing body for tennis in Great Britain. So first of all, I'm going to outline the theoretical approach that I use in my PhD. So as Joe mentioned, that's representative learning design. But we can really talk about how we might use this to assess practice design in a wider range of sports as well. And then I'm going to take you through a subset of my most recent data collection from my PhD. So representative learning design is a theoretical framework based on Egon Brunswick's representative experimental design, and it can really be used as a tool to design and evaluate practice tasks. And what we mean, if this works, when we talk about representative design. So for me, this is my performance environment, and if I'm thinking about what I want to try and do within a practice task that I'm designing or a coach is designing, we want to model our training task to represent as much as possible the performance environment, the information that are available to the athletes, and the decisions that they have to make when they're playing in that competition. This is a French Open match with Joe Conter and Sloane Stephens, so this is kind of the top competitive environment. And the criteria that we might use to try and design a representative task includes action fidelity, so that's basically when the participants are able to respond in the same way in a training environment as they would in a performance environment. So in this situation, that would mean that we're giving players the same opportunities to make tactical decisions, we're challenging them in the same emotional ways in training as we would do in match play, which is obviously quite a hard thing to achieve. And also the second criteria for representative learning design is that we preserve the functionality of perceptual information. And what that means is that our participants in our training environment are able to perceive and act according to the same information that they receive in this performance environment. So in this case, that would be the participants are able to respond to the same intensities, the same pace, trajectory, spin of the ball. They're responding to their opponent. They can read informational cues from their opponent's body language, their court position, and that's what we're really trying to achieve when we design representative tasks in tennis. So if we meet these criteria, then we could confidently say that in our training environment, we're promoting effective skill development, and there's a good transfer of training to our sport performance environment. So to give you an example of how practice has already been evaluated in tennis, there has been a tennis-specific representative practice assessment tool, bit of a mouthful, so we'll go with another acronym of the RPAT. This was developed by Tennis Australia quite recently, and it uses the framework of representative learning design, and it's created a questionnaire that's been developed by elite coaches and practitioners in the sport. It's not been used extensively in tennis research so far. One method that has been used more extensively is notation evaluation. So for example, charting is really common in tennis, so coaches use charting a lot, and that might be manual charting, just using pen and paper, but also performance analysts will create specific tagging panels for coaches and players based on what they work together on. The movement demands of tennis have also more recently been evaluated. So for example, video-based systems, so non-invasive, just video-based system, will look at player tracking metrics, so distance travelled, player velocity. Player velocity and distance travelled were also measured in tennis by GPS, although there's some controversy about how appropriate this is, given that tennis is a small court-based sport with multiple directions in quite a tight area. Accelerometers and inertial measurement units can also give a proxy for the forces experienced by tennis players during changes of direction on court. And more recently, with the kind of advent of Hawkeye in more prominent competitions, Hawkeye can also be used to measure distance travelled in point between sets and matches, and also player velocity, although there is again some discrepancy about how valid those measurements are. And no one really knows how Hawkeye has kind of developed these metrics, so that's maybe to be taken with a pinch of salt. The other thing that Hawkeye has done is kind of enhanced notation evaluation, so we can really get richer information on the ball flight, ball pace, ball spin in matches. So I'm really interested in what happens during performance tennis training, so my kind of docket with the with the LTA is to try and get to know what happens during performance training so that we can enhance the learning environment for our athletes, and in the end that creates better, more successful British tennis players. And the previous methods of analysis that I've used have been often used in isolation, but what I think is really important and what I'm trying to do throughout my PhD is really take a multi-dimensional approach to understanding the practice environment. So I'm trying to use these tools together in a synergistic way to try and provide a better way to understand practice design from a technical, tactical and physical perspective. As I said, this is to inform and improve player learning experiences and also to inform coach behaviours. And today I'll show you why I think we need to evaluate training environments in this way using a subset of my PhD data. So the way that I collected my data throughout my PhD is to visit junior national age group performance camps. So these are the top 8 players, girls and boys for their age group. And they take place on indoor hard courts mostly at the National Tennis Centre in London. So the data that I collected throughout my PhD has been whole court video. So this view that you can see up here, that would be the view that I've recorded for training and match play sessions, which I use for my notation analyses, so to create my own tagging panel. I also asked my participants to wear a triaxial accelerometer, which records at 100 Hz and is mounted on their sacrum, so on their lower back. And within these training sessions, players take place in a lot of on and off-court sessions. I'm mainly focused on the on-court sessions. And the way that the coaches prescribe training, they have 3 types of tennis session that happen throughout the week. So there's a drills-based session, which really consists of blocked repetitions of specific shots or specific patterns of play, which are repeated at high intensities for specific durations of time. The other type of training session that coaches use is a skill-based session, so that's much more coaching input, more stop-start in play, much more skills-based in terms of developing serves, returns, volleys, and tactical awareness. And they also do a session of simulated match play at the end of the week where coaches match up players based on who they think would be a good kind of competitor for them. So within each session, a number of tasks are prescribed, and what I'm showing here today is really a subset of data for one type of task, which is the point play task. So this is the RPAT. So as you can see, it's a questionnaire consists of 7 questions, and each part of each question consists of the task goal for the first part, and then also the second part of the question consists of how well that task relates to a competitive environment. And at the end of it, you get a score out of 70, down here. And the reason that I chose this task, point play, was because it scored the most representatively out of the tasks that were prescribed in this camp. And I'm going to try and show you an example of what that point play task looks like, if I can. Probably not. Yeah, so there it is. I just love it when technology works seamlessly. Oh, so close. Right. Okay, so if we think back to our performance environment previously, we can see that this task is representative. You've got 2 players playing against each other. The point is started by one player in the foreground serving to the other. So in terms of general tennis point play, that is quite representative. What makes this less representative, so why it would have got less than 70 out of 70, is that the player in the foreground is obviously choosing what side he can serve from. So he served from reduced court twice. And then also this player in the foreground is playing as part of a team, so he's in a pair against the player on the other side. The games are played up to 10 rather than a normal kind of games-based 15, 30, 40 kind of system. And so that would be why less representative. The coaches in this example actually were asking players to move forwards as much as possible. So the point of this session was to develop serve and volley play. So players and moving forwards into the court and the returner is trying to exploit the space at the net as well by using passing shots. Oh, that is definitely not my presentation. It's trouble when you leave YouTube running. So, moving on to my next method of analysis, this graph shows the proportion of types of shot that are played during a points play task on the left and a simulated match on the right. So here the proportion of serves played, so this box here, is larger in the point play task in comparison to the simulated match, and the proportion of ground strokes played in the points play is lower in the points play than the simulated match. So even though the RPAT has suggested that this is the most representative task out of all of them, the notation analysis does demonstrate that there are some differences between the task studied and the simulated match play. And these differences in proportion of shot type could be explained by the proportion of shots in and out. As I said, the coach constraints meant that players were moving forward as much as possible, which meant that the points were shorter. And if points are shorter, due to approaching the net more often or being more aggressive, these data hint that there are changes to tactical behaviour, which means that the action fidelity from our performance environment is less representative. And my thoughts about this are that the points-based tasks aren't creating the same sense of consequence as the simulated match play. So players are playing it safe in simulated match play, or they're more afraid to miss. They might tighten up a little bit, which isn't happening in the points play. So moving on to the movement analysis, this figure presents acceleration data for one participant during my simulated match play and point play task. So the magnitudes of accelerations are shown along the radial axis here in G, so this number is in G's. And to give you some context to that, the accelerometer that I was using measured up to 16 Gs, and we did measure accelerations at a maximum of 15 Gs during tennis play. So these accelerations are low, and they are much lower than I anticipated for these data. The direction of the accelerations is shown around the circumference here on the angular axis, and that's in degrees. So if you were standing on the 0 on the origin here and facing 90 degrees, that would be at the forwards movement and so on. And what this figure shows is the 75th percentile for accelerations in different directions. So that means that 70% of the accelerations in different directions take place within these highlighted areas here for each type of activity. So as I said, the intensity of accelerations are lower than I expected, but the intensity is higher for the simulated match play than the points play, and in some cases that's twice as high, so it's a 100% increase from the simulated match play to the point play task. So again, we're seeing some differences in the physical demands of this point play task in comparison to the match play. The spread of accelerations also occur in a different pattern for the simulated match play. So for the point play task, they're all clustered around this kind of central region, but in the simulated match, the pattern is kind of flatter, and that suggests to me that there are higher intensity lateral accelerations occurring in the simulated match task in comparison to the points play. In both scenarios, however, there is a higher acceleration towards the right-hand side of this grid here, which suggests to me that players are experiencing higher accelerations on the forehand side for both tasks. And in the lower left-hand corner here, the simulated match play is the participant is experiencing higher accelerations in a simulated match play, which suggests to me that they're experiencing higher accelerations towards the backhand side. So maybe an indication of more defensive play in that scenario. So in summary, the RPAT has suggested that we have a representative or fairly representative practice design, but when we look at some other methods of analysis for the same task, we can see that there are some differences between the prescribed task and the simulated match play. And this is a subset of my data, so there's obviously some limitations with that, but I think this method shows, the kind of triangulation of data shows this is quite a powerful method to really understand what's happening within each method of evaluation. So in conclusion, I would say that using measurement techniques in isolation can lead to incorrect conclusions taking place for a specific practice task. For the data that I've shown you today, the technical and physical aspects of training are less representative than our CAT score might suggest. So a synergistic approach is really beneficial and provides us with a rich evaluation of practice design in tennis. And what I hope to feed back to the LTA is that the use of these methods together should really help to inform coaching practice and really help us to develop effective but enjoyable learning environments for the players that are coming from this approach to the system. And that's particularly important now because the LTA have just opened up their new national centres and they've got a very structured regional performance programme. So hopefully this information can be fed into that programme to help promote effective learning environments across the whole spectrum of players. If anyone's interested in looking at the RPAT, it's really accessible. It's this, I can see it.